Okay, so this video is only 10 minutes long, and it's really just to show you what you were supposed to do on these different problems, okay? So this is kind of a answer key meets work through, okay? So here's our answer key. All right, and of course there's an announcement right there as I do that.
Also, Ms. Parker, you can please call the front office. Ms. Parker, the front office.
All right. So with the question, the first question, what's the initial amount? Well, remember when we're talking about exponential equations, this is my initial amount. So the $400, that's all we've got. So that was a quick one. Now the interest rate's a little trickier. So remember that our equation looks like this. A equals P times 1 plus R to the T. Well, your issue here is 1.09 is what's in parentheses here. Okay, so we have to kind of work backwards. So to get 1.09, you could think 1 plus 0.09. If I add that together, I get 1.09. So 0.09 is the rate, but that's the rate after we've changed it. We've used percent or applied percent. Remember, percent means out of 100. Well, we want to go backwards here. Remember, to get the number we need here, we usually divide by 100. So to go backwards, we multiply 0.09 times 100. And we get 9. So 9 out of 100 would be 0.09. So 9% is my answer. Okay? And the amount of money I'll have in 10 years is actually the easiest part of the problem. You're really just typing that into the calculator, and you're getting, let's see, 10 years, $946.95. Okay, and the way we did it is we literally just put into our formula A equals 400 times 1.09 to the 10. Now, I may not do that one for you. That one, I think on the next problem, you're going to have to do that yourself. So when I check this, I would expect that to be filled in by you. Okay, now this one's trickier. Okay, so now we have the formula, but I've given you the A equals, it's the compound interest. Compounded like quarterly, monthly, more than just yearly. So the initial amount, though, stays consistent, right? My $500. So $500 is my initial amount. The trick is the interest rate. So let's go backwards. The 1 plus R over N is where the interest rate's coming from. Well, I have 1 plus 0.01. Okay? Now this one's tricky to get to. Now what you can notice is that 12 is up here. Remember, if 12 is up there, then this would also be 12. N would be 12 here. So 1 plus blank over 12 is what we would have. So 0.01, let's just put R, we don't know. 0.01 would equal R over 12. Right? This would equal that. They would equal each other. So if I multiply by 12, I get 0.12, which makes sense. If I'm splitting 12% into 12 pieces, I'm going to have 1%. And you might be like, how do you know it's 12%, Mr. Duncan? Well, remember, this is with the percent applied as dividing by 100. So if I want to write it as percent, I multiply by 100, and I get 12%. Now that's tricky. I would love if somebody came up and said, hey, what did that mean? You know, and I've kind of already answered this one actually. So we'll go ahead. How often is the interest compounded each year? Well, this 12 is revealing that. The question is, what happens 12 times a year? Like, what measures that? Is that quarterly? Is it monthly? Is it semi-annually? Is it daily? Well, there's 12 months in the year, so it's compounded monthly. Okay? Now, I hope we're processing through and not just copying. So make sure you're getting the hang of these and ask me questions. If not, I might even say, ask me some question on them. All right. So write the following two equations so the rate of growth or decay is represented. This sounds scary. It's not really. A equals, remember we do 1 plus or 1 minus, right? So in this one's the easier of the two. 1 plus what would be 1.23. 1 plus what would be 1.23. Well, the answer is 0.23. Whoops, that's a 5. Now this one's a little trickier. A equals 80. This one's less than 1, so 1 minus something to the t. Now, a way that you can find this, if you do 1 minus 0.72, you will get the number that needs to go in there. So if you do 1 minus 0.72, you'll actually get the number that should go in right there, which ends up being 0.28. So 28% is dropping by 28%. See, guys, what this is saying is this is 72% right now is what that's telling me. So if it started at 100%, remember everything we have is starting at 100%. If it drops to 72%, it's dropping by 28%. Okay? Now, prove that these expressions are true algebraically. Well, or in words. I'm going to let you think about that. I want to see what you come up with. I'm not going to do that one for you. Okay? Number 5, you should also be able to do. Okay? But I'm going to write the equation with you and leave A and B for you to complete. So A equals our initial amount, which is 1.15, 1 plus, okay, 1.92%. Hey, man, if you change it, somebody just walked in. So if you're like, why did he just yell, hey, man? 1.92%, if I change that to, like, if I do 1.92 divided by 100, I get 0.0192, okay? And I'm putting it like I'm going to do a fraction, but you know what? It's annual, so I'm good. And then to the t power. So there's my formula. And then you guys can answer A and B. All right, so this next problem, number 6. So you buy a used car, it depreciates. So that means it's going down by 12%. Well, remember, if we want percent, a lot of you say, well, how many places do I move the decimal? If you're not sure, divide by 100. So 0.12, because percent means out of 100 or per 100. So if I do this problem, y equals 17,900, my initial amount, 1 minus 0.12 to the t. Now this would be 0.88 because you're dropping by 0.12 or 12%. If you wanted to simplify it, that's fine. Okay? I'm going to do the first chart value, so you'd have 17,900, and the second. So the second one I would do, really you're doing 17,900 times 0.88. So 15,752. So 15,752. And then if you wanted the second one, you would multiply by 0.88 again. Or you could put to the second power in your equation. All right, I'll do one more. $13,861.76. Okay, so finish these questions. All right, and I'll check those in just a bit. And then number 7, you can pause it, by the way, and do each problem if you want to as we go. So this is the different equations that we had. If an interested, I'm not going to do every one, but I'll do the first one. So if we do the final amount, we've got an initial amount of $4,000. 1 plus our rate, 5% is 5 out of 100 or 0.05. So 0.05, but here's the deal. It's compounded monthly. That means I'm going to get paid 12 times. So that 5% is going to get split into 12 equal pieces. And then I would raise that to the 12t because I have to get 12 payments per year. That's all I want in B and C. Now D asks how much would you have in 5 years? So there I would actually put, and I'm doing that in my calculator right now, 1 plus 0.0, 4,000 times 1 plus 0.05 divided by 12 to the 12 times 5 power, which is 80,000. No, I did something wrong. Oh, yep, sorry, hold on. That's way too much money. I did not put my division sign. It did not work. Second, insert division. There we go. Now let's give you an answer. $5,133.43. Okay, so you have to come up with your other two equations, weekly and daily. Now, weeks, there are 52 weeks in a year. Daily, there are 365 days in a year, in case you weren't sure. Although you could look that up if you needed. All right, almost done. So you can finish that problem and then come on to number 8. Number 8, okay, you're doing a chart. So you realize that a single bacteria, so this is going back to like day 1 of class almost. So on not day 1, on 0, at the very beginning, you've got one bacteria. But a month, or is it a day? Okay, every hour. So next hour is going to be double. Next hour, it's going to be double. So we're multiplying by 2. So let's talk about our equation. So our initial amount is 1. And we're multiplying by 2 each time to the however many power, to whatever power. Okay? I'll let you create the graph. Okay? And then the last question, question 9. So you've got 2 situations. Okay? So if you look at the first one, and these are the types of questions that the state is wanting you to be able to do. And they're good questions. It's not just they want. Sometimes I'm like, yeah, but this is good. So you've got $8,000 per year with a $1,000 increase. That's company A. Think about it. That is continued what? It's increasing by 1,000, but so that's adding 1,000 every time. So company A is linear. Company B is exponential. Okay, so I want you to find both of those equations and find when company B will be higher than company A. Clearly, company A is higher to begin with. Okay, maybe it's never. Okay, you can use Desmos to think about that. So once you decide that, which is the better offer? That's a real life situation. Okay, that's it of the video. Finish the questions not completed on those 2 pages. And yeah, and we'll continue with our lessons the next day. Have a good day.